Hello everyone, this is Dr. Gajanan Jadhav. I'm working as an assistant professor in Sri Shivaji Education Society, Amravati Science College, Congress Nagar, Nagpur. In this video, we will study the introduction to solid state physics, solid state physics, and the definition of solid state physics. So we will begin this with what is solid state physics. We know that matter is usually regarded to exist in the solid state or the fluid state, the latter being subdivided into the liquid and gaseous states. However, on the basis of the modern concept, the matter is more conveniently divided into the condensed state and the gaseous states, the former being subdivided into the solid and the liquid states. So it's not easy to give completely satisfactory definition of a solid. So a borderline material can always be found. So we shall use a solid to mean any material whose constituent particles like atoms, ions or molecules are relatively fixed in position except for thermal vibration. So solid state physics, basically it is the branch of physics which deals with the solid state material and the physical properties of solids, focusing on their electronic, thermal, mechanical and optical characteristics. So this is what we call it as a solid state physics. Now let us move on to classification of solids. Now basically solids can be classified into three categories. The number one, crystalline solids, for example copper, iron, etc. are the crystalline solids. Number two, semi-crystalline solids, which is also called as the polycrystalline solids. Number three, and examples are polymers like polyethylene, polypropylene, nylon, Teflon, etc. And number three is the non-crystalline solid, or it is also called as an amorphous solid. And examples are glass, plastics, rubber, gels, wax, etc. Now we know that crystalline solids having the atoms which are regularly arranged, that means there is a regular arrangement of atoms, either it is in 1D, one dimension lattice, or we call it as a one dimension lattice, or these atoms will be arranged in two dimension also, so we call it as a two dimension lattice. So here in both these one dimension lattice and two dimensional lattice, there is a periodicity of these atoms, that means all these atoms are regularly arranged. As far as the semi-crystalline solids are concerned, which is also called as the polycrystalline solids, these atoms are, there is a regular arrangement of atom, but that periodicity is localized periodicity. That is, for this much of what we can say the part will be periodicity, and then there will be another part where you will get the another periodicity. So that will be localized, and this is what we call it as a grains. So this happens in the semi-crystalline solids. As far as the non-crystalline solids are concerned, there is a atom, there is an irregular arrangement of atoms. That means atoms are randomly arranged. There is no any periodicity. So this is how we can classify the solids in the uh, in three types. One is crystalline solid, semi-crystalline solid, and non-crystalline solid. Now let us move on to the next, which is very important. As far as there are different properties of crystals, we know that there are different properties of crystals. So one of its property is shape and its structure. So if you look at this a cube, then you will find that there are uh, 6 faces and 8 corners are there, as well as 12 edges are there. So if we want to find out number of edges or corners or edges, then we are having the formula, or we are having that relation between these three, that is number of faces, number of angles, or you may call it as corners, or number of edges. So it can be written as f plus c is equal to e plus 2. And if I want to find out any of it, suppose let us say if I'm given the number of faces is equal to 18 and the number of angles is equal to 14, then I can find the number of edges. So simply I will put these values in above formula and I will get the answer. So I'll get the number of edges is equal to 30. So this is how we can find the number of faces, number of angles, as well as number of edges with the help of this particular cube. Now let us move on to the next, which is very important as far as the crystal is concerned, and that is nothing but the unit cell. Unit cell is nothing but the smallest repeating unit in a crystal lattice that when replicated in 3 dimensions forms the entire crystal structure. That means this is a single unit which is getting repeated throughout that particular crystal. That is what we call it as a unit cell. So here different combination of unit translation in a plane lattice is there, and these unit cell you will get in 2 dimension as well as in 3 dimension also. So in 2 dimension here is the position vector A, then there is a position vector B, by which we can show that there is a one unit cell. So this is what we call it as a unit cell. Now with the help of these unit cell we can find the translation vector also. Now let us move on to the next, which is very important as far as the crystals are concerned, and that is nothing but the fundamental translation vector. Now what is the fundamental translation vector? For that purpose we need to understand that there is a regular arrangement of atoms, and when we want to find out the position of one atom with respect to other, then we define it by the position vector. So we have a position vector A, position vector B, and then with the help of which we can find the translation vector. So translation vector in 2 dimension will be equal to n1 A plus n2 B, whereas n1 and n2 are nothing but the integers and A and B are nothing but the position vector, and T is nothing but the fundamental translation vector. Similarly, we can find the fundamental translation vector in 3 dimensional lattice also. Like here we are having the cube. So here this is position vector A, B and C. So the angle between B and C is denoted by alpha. The angle between C and A is denoted by angle beta, and the angle between A and B we denote it by angle gamma. So alpha, beta and gamma are nothing but the interfacial angles between the 3 planes. So this is a primitive cell. So in 3 dimension lattice or in a primitive cell we can find the fundamental translation vector with the help of position vectors, that is A, B and C. So how do we write? We write it by T is equal to N1 A plus N2 B plus N3 C, whereas N1, N2 and N3 are integers, A, B and C are positive vectors, and T is nothing but the fundamental translation vectors. Now let us move on to the next topic, which is very important as far as this crystal is concerned, and that is, we know that as we have been discussing that there is a regular arrangement of lattice points. So at every corner there are these lattice points. That means if we consider a primitive cell, then these are the 8 points where there will be a lattice point. These 8 points are called as a lattice points. Now this is nothing but the lattice. If these lattices are, that means if we add lattice and basis, so basically basis is nothing but the atoms or ions, So basis is nothing but the basis is also called as a motif, and these are nothing but the atom or ions. So lattice plus basis, it gives us the crystal. This is how we'll get the crystal. So this is what we call it as a crystal. So basically crystal structure is nothing but the lattice plus basis. This is how we'll get the crystal. So lattice points are nothing but the imaginary points which shows the position of atom, and if you add it to the atom or ion, then we call it as a crystal. That means lattice plus basis is nothing but the crystal. Now let us move on to the next, which is very important as far as this solid state physics is concerned, and that is nothing but the crystallographic angles, axis and the corresponding angles. So here we are having A, B and C. These are the three position vectors where the angle between B and C we denote it by alpha, angle between C and A we denote it by beta, and the angle between A and B is denoted by angle gamma. So here A, B, C are nothing but the position vectors, and alpha, beta and gamma are nothing but the interaxial angles. So that's it. Thank you so much.